Okay, so today we're going to start section 1.2. It's day 2. 26 left after today. We're just moving right along, but it's day 2, and we're going to take a look at applicant linear problems, right? That's one that's just going to have an X in it. And the other day we talked about rational. That's one that's going to have a fraction in it. It's going to have some sort of ratio. And these are equations. So we did linear equations and we did rational equations on Tuesday. So now we got to do the real life thing and turn word problems into these types of things. Read the problem carefully. You can go through and read all these. I just start, I could summarize this by maybe read it twice, write stuff down, and see what starts to happen. So we're going to jump right in, and Carlos is borrowing $8,000 from his mom and the bank. So let's see, M is going to equal money from mom. B is going to equal money from bank. Boom, look at me getting partial credit on a test. Let's see, that 8,000, a total of 8,000. He borrowed a total of 8,000. So if I knew how much was from mom, like say he borrowed 1,000 from mom, how much would be from the bank? If the total is 8,000 and he borrowed 1,000 from mom, how much is from the bank?
7,000.
7. How'd you get that?
Subtract 8,000 from 1,000.
Yeah, I'm doing it. So bank is also going to equal 8,000 minus mom. Sound good? And he's going to start up a food truck. Well, that's good. I don't know if there's a lot of money in food trucks, is there? Unless you own like 10 of them. Anyhow, the bank charged 5% interest. So the bank interest is 5%. And mom's interest is 1%. But you have to call her more often. If the total interest after 1 year equals $280, oh boy. Okay, so here's what we got going. I got let's see, if the total interest is $280, we know that. So over here we're going to have a column called interest. And let's see, we're going to try to get an interest that he had to pay mom. And an interest.
Can you move the paper down?
Sure.
Thank
We're going
you.
to have to get the interest that he had to pay to mom and the interest that he had to pay to the bank. Okay. Well, how much money was it? What was the amount he got from mom? We don't know. We called that M, right? How much was from the bank? That's 8,000 minus M. The interest mom charged was 1%. So this is interest here, and this is 0.01. So for example, if he borrowed $5,000 from mom, and again, this is the rate of the interest. The interest he'd have to pay her is that 5,000 times 0.01, and that's how much he'd have to pay her. It's a hard problem. Do a couple of these and they get much easier. But right now it's a hard problem. Whatever the amount was that he borrowed from the bank at the end of the year, he has to pay 5% interest. And that's how much interest there's going to be. So the interest for mom is 0.01 times M. The interest he pays to the bank is 0.05 times 8,000 minus M. Every once in a while, I need to sit back and think, okay, this is the money from mom. This is the money from the bank. At the end of the year, I have to pay mom 1% interest. So 1% of that money goes to mom. At the end of the year, I have to pay 5% interest to the bank. So 5% on the bank amount equals this. Well, I do know the total interest for 1 year is $280. So it's going to be the interest that I paid dear old mom plus the interest that I paid the bank. And I know that has to equal $280. Classic. Oh, when he shows me how to do it, I understand it. All I did is just start writing things down. Here's the money. I knew there was some interest rates and I needed to find the total interest I pay mom and how much interest I pay the bank. And those two have to add together to be 280. My pen's down. I'm going to let you do the work from here. This is what we did Monday or Tuesday. Distribute away, combine things, work with decimals. It's okay. We're going to find an answer for M. And the question wants to know, how much did he borrow from mom? How much from the bank? That's 1 2 decimal places. That's 1 2 decimal places. 80 times 5, I'm guessing that's going to be 400. Sound about right? Minus 0.05 M, 0.01 M equals 280. Shoo-ba-doo-ba-doo. Fire some answers up in the chat when you get them. How much? Right now, we're just solving for M. The whole problem is M and B. So I'm going to have to plug that in. Shoo-ba-doo-ba-doo. Negative 0.4 M equals negative 120. Use your calculator. Everybody has a phone. Everybody has a calculator. Mom is 3,000. That sounds legit. That sounds legit. If I divide by negative 0.04, yeah, there it comes. It's coming fast and furious now. Mom is 3,000. Thanks, Mom. Bank is 5,000. Cool. Cool. What do you think about that? Good. Questions? All right. And again, I did get that recording up somewhat quick the other day for the first day of class and the other one. Oh, I like this new mixture problem. This is almost as much fun as the one I gave you on assignment 1. But so we have trail mix, we have candy mix, we have party mix. We're going to put them all together. We're going to take the trail mix and the candy mix and put them together. Okay. Now they go horizontally. I normally go vertically. I like a different representation vertically. So I'm going to change this one just a little bit. And I'm going to say, okay, we have the 10% of trail mix. We have 40% of candy. And 12% is the two mixed together. Okay. What these guys together for? At least you combine low fat trail mix with higher fat candy. How much? 10% should you? Okay. So now I'm going to have amounts as I see up there. And true or false, if I had 5 pounds of trail mix and 10 pounds of candy, how much is going to be in the mix? For example, if I had 5 here and 10 here, how much is going to be in the mix?
20,
5 and 10 together is
15, sorry.
it's going to be 15. So these two are going to get added together to give me what's in the mix. Well, let's see what I know about the amount here. So I'm going to start with amount as this first column. Low fat with high fat. How much should she mix with 4 ounces? Oh, this is 4 ounces. This is what we're asking for. How much 10-ounce fat trail mix, we'll just call that fat trail mix. Well, we just said, if I add, well, yeah, this is gonna be F plus 4. Agreed? That's gonna be F plus 4. Okay, that makes sense. It kind of makes sense. Okay, the percentages are gonna become important. 0.1, 0.1, 0.4, and 0.12. Okay, so I have that and I have that. I have the amount, I have its percentage, and what I'm going to get over here is some kind of a total, a pure fat total or something. So this is now going to become like an individual total. So this would be 0.1 times F. This is 0.4 times 4. And this is 0.12 times F plus 4. Well, what's happening here is just like we had the amount F plus the amount 4 is what we have in the mix. The individual total, this amount of pure fat plus this amount of pure fat, has to equal what's in the total. So we just came up with our equation. What's in the 10%, 0.1 F, plus what's in the 40%, I'm going to multiply those right now. I know somebody's ready to catch my error. Has to equal what's in here in the mix. Okay, so just like the amounts, these individual totals, the first two has to be the same as the second total. And now we have a problem. We can solve 0.1 F plus 1.6, 0.12 F plus 0.48. Do your thing. I know what I'm going to do. I'm going to multiply everything by 100. We looked at an option like that on Tuesday. If I multiply this by 100, it moves 10 decimal places. 10F plus 2 decimal places. 160 equals 12F plus 48. I made it something that I'm more familiar with, and that's okay. I made it more familiar. I multiplied everything by 100. I'm confused. How did I get 0.12F? Down here, this percentage in the mix was 0.12. Okay, so just like I multiplied the amount by the percent of fat to get an individual total, I did it for all three of them. And I know that the two individuals have to equal what's in the mix. So my 0.1 F, this becomes 1.6. This becomes 0.12 times the F plus 4. Yes, so now I distribute to 0.12. I got 0.12 F plus 0.48. Good. Let's see. I'm going to bring the 48 over. This is going to be 2F. Going to bring the 48 over. That's like 112. Whoop, whoop. Looks like I'm going to get 56. So that means 56 of this, and 4 of this is going to give me 60 ounces total. And it looks, yeah, this percentage is mainly trail mix because it's pretty close to 12 as opposed to close to 40. Again, the first time you see these, they're hard. The second time, they get a little easier. The third time, a little easier. All righty. Did you get the 10 from the trail mix? This 10, Shaquana,
Yes,
Okay, so remember this 0.1 up here in the trail mix? Gave me 0.1 F. Well, I wanted to clear my decimals, so I multiplied everything, all four terms by 100. When I do, it moves it 2 decimal places. One,
okay,
2, what, yeah, and so forth.
gotcha.
All right, all right, all right. We all know this to be true. If I see distance, I see time, I see rate. What's the formula? You've had it in 8th grade. Might be a long time for some of you, longer for me, just saying. Distance. Somebody say equals.
Equals.
Equals. Oh, come on. Okay, we knocked the rust off. Some of you are gonna say, oh yeah, distance equals rate times time. Distance equals rate times time. Oh, distance equals rate times time. Okay. I want you to take a minute and see what boxes you can start to fill in. There's 6 of them there. Daryl's distance equals rate, his rate times time. And remember, distance equals rate times time. Rate is probably going to be miles per hour. Time should probably be hours. So I end up with a distance of miles. Remember the other day we were talking about how important labels are. So I want to make sure I'm doing miles, miles per hour, hours, and so forth. Daryl and Cindy leave home at 7 a.m. heading in opposite directions. So they start here. This is home. Daryl goes this way. Cynthia goes this way, and they never look back. Daryl usually spends 30 minutes biking to work. What's Daryl's time?
30 minutes.
30.
30, but what do we think we might want to make it instead of 30?
0.5.
Yeah, 30 minutes equals 1/2 of an hour. Because remember, our labels are going to have to stay important. Cindy. Okay, we're back. 20 minutes. That's going to equal 1/3 of an hour. So far, so good? Okay, yeah. Cindy is 7 miles per hour slower than Daryl's speed. What's Daryl's speed? Give me the classic answer. Say, I don't know.
X.
X, yeah, something. How about S for speed? Daryl's speed is S. Cindy's is 7 miles per hour slower than Daryl's speed. Ah, I'm done. My work here is done. What is the distance for Daryl? Rate times time, 1/2 S. What is the distance for Cynthia? Rate times time, 1/3 S minus 7. They work 6 miles apart. So Daryl goes this way, Cynthia goes this way. What do I know about their distances? They have to no, not equals. They're going in opposite directions. So this guy right here is 6. So he left home and got to his work. She left home and got to her work. And that distance, B plus C is going to have to equal 6. 1/2 S plus 1/3 S minus 7 has to equal 6. Yeah, 1/2 S plus 1/3 S minus 7/3 equals 6. There's another one of those rational ratios. The fraction, I want to clear the denominator. I'm going to multiply everything on both sides by what? Six. 6. Going to multiply everything over here and everything over here by 6. All right. This becomes 6/2, which is 3. This becomes 6/3, which is 2. This becomes, oh boy, minus 14 equals 36. What is Daryl's speed? Looks like Daryl's is 10. Cynthia is 3. Cynthia doesn't move very fast. Cynthia's walking uphill. Daryl is walking downhill. Because you didn't know this, they live in San Francisco where it's really hilly and she has to walk up to the top of the hill to work, but he gets to walk downhill because he works on the docks. And I'm just making all this up in case any of you are wondering. It's a good story, right? Emily, nod. Yes. Questions?
I was so confused at first because I thought they were driving. So I'm like, who's going 10 miles per hour down the street? But I understand now.
Oh, here we go. Daryl bikes to work. That's why he goes so fast and she walks. It wasn't downhill. By the way, that updated assignment sheet that I put out for you, section 1.2 is like the first 3 problems. And they're a little more challenging. Don't wait till the last minute. All right, here we go. Malcolm and Jamal. Blah, 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 blah. I don't have to read it to you. You can read it, but looks like they're going to clean out a garage. All right, let's see. Malcolm can clean the garage in 3 hours. All right, let's figure something out here this first time. So if Malcolm can do it in 3 hours, how much of the job would he have done in 1 hour? How much would he have done? If it takes him 3,
1/3.
yeah, he'd have 1/3 done. And say Malcolm worked 2 hours, how much of the job would he have done?
1/2.
2, if it takes him 3, right? I know he clean out the, where are we at here? Malcolm can clean it out in 3 hours. We're still talking about Malcolm. And if Malcolm worked 2 hours, he'd have 2/3 of the job done. So this is what he worked. This is how long it takes. Okay. So if I don't know how long Malcolm's working, right? I don't know how long Malcolm's working. I'm just going to call that H for hours. Because if he works 1 hour, he'd have 1/3 of the job done. If he worked 2 hours, he'd have 2/3 of the job done. Okay. Jamal can clean the garage in 5 hours. Same kind of deal. If Jamal worked 1 hour, he'd have 1/5 of the job done. If Jamal worked 2 hours, he'd have 2/5. So right now we're saying, okay, well, they're going to work together. Oh, they're going to work together. So after 1 hour, again, Malcolm would have 1/3. Jamal would have 1/5. Did they clean the garage? After 1 hour, if hour equals 1, they'd have 1/3 plus 1/5 of the job done. Did they get the whole garage cleaned? No, because what does that need to equal?
2,
2? Are there 2 garages?
not 1 garage, 2 hours.
Yeah, it's 1 garage. We're not worried about up here yet. There's only 1 garage. So if he cleans 1/3 of it and he cleans 1/5 of it, it's not totally done. I need him to do a portion and him to do a portion so that the whole job is done. So this is going to be an equation where it has to equal 1. I don't know how many hours Jamal worked or Malcolm, but if he worked 1.5 hours and he worked 1.5 hours, would it equal a whole job? Would the whole garage be cleaned? So this is the type of a problem. It's in a group called work problems. You'll see examples like filling a pool and mowing the grass. That's the example I give you on assignment 1. But yeah, okay. Boom, solve it. H is going to be the number of hours they work together. You can do it. Hopefully some of you are off and running. You're saying clear the denominator again. 15 and 15. 15h over 3, that's going to give me a 5h plus shooby-dooby-doo 3h equals 15. Huh, that is 8h. Yeah, boy. H equals 15 over 8, but that's hours. And we're okay. That's 1 7/8 hours. And we did, in fact, answer the question. Can they get it done in less than 2 hours? The answer is yes. I just want to know what the heck's Jamal's problem that it takes him almost twice as long as it takes Malcolm. Is Jamal just lazy? Is Jamal on his cell phone doing TikTok videos? Is Jamal take a lot of bathroom breaks? What's going on, Jamal? You're not carrying your share of the weight. Questions? Nope. The only questions are why is Jamal so lazy? We're going to skip number 5 on here and jump over to number 6. See what we have. In this hallway, Robert has an old rectangular throw rug, and the rug measures 2 by 3 feet. Okay, so this rug, it actually should be in there. So I'm going to have, I don't know why that's off. And here's 2 by 3 feet is the rug. Okay, that's a rectangle. I know stuff about a rectangle. After the spent weekend, I'm going to ask you, well, I'm not speeching very well. He decides to upgrade the rug by adding a new border with the width of X feet around the edge. Okay, so he's going to go X feet this way, X feet that way, X feet this way, and X feet that way. So now I have something that looks like this. Fancy rug. Okay, so now I have a new length and width. and I need to see what they are. Well, each one of these red lines is X. So what is my new width? X plus 3 plus X. My new height, X plus 2 plus X. And of course, we can simplify those. All right, after very much. Good. So now I have 3 plus 2x, 2 plus 2x, and oh, he says the perimeter all the way around is 14. So I'm going to go across the top. 2x plus 3 down this right side plus 2 plus 2x back across this side. That's another one of those 2x plus 3s, and then back up the top. That's another 2x plus 2, and my perimeter has to equal 14. Things that make you go, Determine the value for X. What is X? Who is Batman? Two bananas and two bananas and two bananas and two bananas gives me 8 bananas. A lot of time you see the perimeter formula as 2 times the length plus 2 times the width, because we had 2 lengths and 2 widths kind of deal. 3 and 2 is 5, and 5, that's 10. Dooby-dooby-doo. One half of a foot. Y'all are really quiet. Some of you are just waiting for me to answer, so you don't have to answer. Some of you are in another room brushing your teeth. Some of you are making your sandwich. Any questions? Any questions at all? Okay, that puts an end to 1.2.